Welcome, students. So today I want to talk about the difference between using the proportion versus using the scale factor. So here we have two triangles. We have a large triangle and we have this parallel line to the base that gives us a smaller triangle. And we're trying to find the value of y in this problem. So one of the things that really helps me is to draw the triangles separately. So here's a smaller triangle. And we see the dimensions for the hypotenuse. This is a right triangle, and this is a right triangle. The hypotenuse here is y. And we see that the total height for both triangles is 6, and the height for this other section is 3. So we know that 6 minus 3 is 3. So this must be 3 if this one is 3. So our height is 3. We do not have a base dimension. That's okay. We don't necessarily have to have one because we're looking for y. So if it's not necessary to find y, we don't need it. The bigger triangle is going to be the larger dimensions, and we have this section plus our y. So we're going to write the hypotenuse as 5 plus y. And the height, we know the total height is 6, so that goes here. We still don't have a base dimension. That's okay. We don't need it. So I like to name my triangles, and in this case I'm going to call this the little triangle and the big triangle, just because those letters are not being used anywhere else. It makes it easier to keep it separated. So the proportion method is going to give me the opportunity to compare one triangle next to the other triangle side by side, like on a side-by-side basis. And to do that, I would decide which one I want on top and which one I want on the bottom in fraction form. I think I'm going to do the little over the big. And then you just have to indicate your sides. Which side is which? Well, if this is a right triangle and this is a right triangle, then this is the hypotenuse, right? So for the little triangle, our hypotenuse is y. And for the big triangle, our hypotenuse is 5 plus y. Now for the height, this is the height of our right triangle. On the little triangle, that's 3, and on the big triangle, that is 6. So we have a comparison here of the hypotenuse of both of the triangles and the height of both of the triangles. Now we could easily set those equal to one another and use a proportion statement in order to solve for the value of y. And that would look like this. Basically, just like what it is. Now, to solve it, all you do is put an equal sign, and we know when we have two fractions set equal to each other, we can solve for a missing variable through cross multiplication. So y times 6 would be 6y. And then we would have 3 times 5 plus y, which would look like this, which we would then simplify through distribution, 15 plus 3y. Now we want to get all the y's together, so we would subtract this from this side and do the same thing over here so that we could combine everything. This would cancel, this would equal 15, and then we would have 6 minus 3 would be 3y. So 3y is equal to 15. 3 times y is equal to 15, so that means we're going to do the inverse operation and divide both sides by 3 to get y by itself to find that factor, and that factor would be 5. So y is equal to 5. So we can use the proportion method quite easily to find the value of y. Another methodology is called scale factor. This is the proportion method, and then you have the scale factor method. In the scale factor method, you're going to compare triangles to triangles, not sides to sides. So what that means is we're going to list it as the side over the side and the triangle versus the triangle. So we're going to say the hypotenuse versus the height, and then we're going to have the little triangle. The hypotenuse is y, and the height is 3. And in the big triangle, the hypotenuse is 5 plus y, and the height is 6. We could still use the proportion method, put an equal sign, multiply. It's still basically the same situation, except that with scale factor, we're comparing apples to apples. We're comparing whatever side has numerical values only. So that means in this case the height. This height here goes from 3 to 6. So when we say scale factor, factor means multiplication. So what factor can we multiply 3 by to get to 6? Well, that would be times 2. So that also means that because these are similar triangles, I should be able to multiply this times 2 to equal this. So y times 2 should equal 5 plus y. So I can create a statement based off of this scale factor. Y times 2 is equal to 2y, which is going to equal 5 plus y. So if I subtract my y here to get all of my y's on the same side, I have y is equal to 5. This is a much shorter method, but it requires a little bit more setup. So you have to think about it a little bit more on the front end to have fewer calculations, or you can do less of a previous or a setup thought process and do more calculations. So that methodology is up to you. It really depends on looking at these numbers. Do you have a clear factor that gets you here? If you don't have an obvious factor, then the proportion method may be the one that you want to use. But if it's obvious, like here we know 3 times 2 is 6, then the scale factor might be a better way to go. It might be a faster way to find the same solution. So it's really about knowing which method works best given the values that you are given. So look at your side lengths and determine, can I easily get from here to here using just a factor? And if so, scale factor is the one you need to get to use. However, if this had been a 5 or if this had been an 8, then proportion might be a better option for you. So those are some of the differences and the similarities between proportion and scale factor. You're really going to get to the same answer regardless of which one you use. It's just that one is better in one scenario and one is better in another. And that's all I've got. See you in the next video.